Welcome, everyone. For today's prep, we're going to start looking at the integration by parts technique for calculating integrals. And we're going to look at it just today for indefinite integrals. And it really comes down to a formula here. So we're going to come back to this integration by parts formula. But the idea behind this is we're going to be kind of working with a complicated integral. And we're going to apply this formula so that we get this new expression. Now, this new expression still has an integral that we're going to have to do, but hopefully this new integral is going to be a little bit easier. All right, so we're going to go through the steps of how this works, and then we'll come back and talk a little bit more about this formula. But I think it's going to be helpful. Let's start with an example. Let's start with example 1. So the idea behind integration by parts is the first step, we want to choose u and dv. So essentially, we want to identify the parts of our function. So that's what the first step is, identify the parts. So what do we got here? We're doing the integral of x times e to the x. So our function here has essentially kind of two parts, and they're being multiplied together. Now that multiplication's kind of important. As we'll see, integration by parts is kind of the analog of product rule for derivatives. I kind of flew past it there. We'll probably talk more about that in class. So this product sign here, kind of a tell that maybe we might have to use integration by parts. But in any case, let's see how this works. So we got two parts of our function here, x and e to the x. They're being multiplied together. And we're going to talk more about the specific strategies on how you do this. But for right now, just kind of go with me here. We're going to let u equal the x. And we're going to let dv equal the e to the x and dx there. So we'll see strategies on how do you know to pick this and pick that. Right now, just kind of bear with me as we go through this example. All right, so that's the first step. The second step then is we're going to calculate the differential du, and then we'll calculate what v is. So kind of right underneath this, let's write du. And this is the same kind of differential that we were working with when we did substitution rule. So we just differentiate the function x to get 1, and then multiply by dx. So we get 1 times dx, and I'll just write, we don't really write multiplication by 1. So, technically there's a 1 times dx here, but we don't need to write the multiplication by 1. So what we did there is we differentiated. Okay. Now, over here we have kind of a derivative, and we want to recover what v is. So the way we undo a derivative is by integrating. So we're going to take our e to the x function and we're going to integrate that. And when we do that, we get e to the x. All right, so that's the first two steps here. So you choose u and dv, and then you differentiate one, and then you integrate the other. So now we kind of have all the pieces that we need for our integration by parts formula. So we have u, we have dv, we have du, we have v. So let's go back now to the formula and see how this thing works. So here's our main formula here. So the integral that we're starting with, the integral of u dv, that's the complicated one that we're trying to figure out. So let's kind of keep track of all this. So we got u, dv, and then du and v. So these were the first two steps. We get all the different pieces of our function here. And if we multiply these terms along the top and integrate, put the integral sign above it, that gives us this piece here. Then the way this formula works is this complicated integral is equal to u times v. So we can think of that as just multiplying down the main diagonal here of our little grid, so u times v. And then v times du, we're going to integrate that and actually subtract off that integral. So you can kind of remember this integration by parts formula as this kind of backward Z shape. So when we multiply these two top terms together and integrate, that's the original integral that we're trying to work with. And what this formula says is that's equal to u times v minus the integral of v times du. And we still have to finish integrating this, but it hopefully is going to be a little bit easier. So let's see how this applies to our example. All right, so we've done steps 1 and 2 here. So now step 3 is actually, let's apply the formula. So again, how does that formula work? Well, the original integral we're trying to do is u times dv, so x times e to the x here. So that was the original integral we're trying to do. So the formula says this is equal to u times v. So x times e to the x. This is our u times v here. Then we subtract and integrate, and then we multiply these terms along the bottom here. So v times du. So e to the x times dx. So that's what our formula says. All right, so, well, we've applied the formula. Now what? Well, the remaining integral that we still have to do is a little bit easier. So notice that we went from having x times e to the x. Now we just have the integral of just e to the x. So this is a little bit easier. And that's actually something we can do. So our last step here, step 4, is to actually finish integrating. So we're still going to have an integral to do here, but it's hopefully a little bit easier. So the integral of e to the x, just e to the x. So this whole first piece, we're done with that, so nothing's going to change there. So we'll still have that x e to the x. And then finishing off, the integral of e to the x is e to the x. And then we have this subtraction sign in the middle there, so let's keep that the same. And then we're doing an indefinite integral, so let's not forget the plus c there. So there we go. We got our antiderivative. So this is more or less the idea behind how this process works. Now we'll come back, and in class we're going to see that we'll talk a little bit about this. Actually, integration by parts is kind of the analog of our product rule for derivatives. So it's going to kind of undo the product rule that we learned about when we were doing derivatives in Calc 1. So the main strategy here for how do we choose u and dv, that's ultimately kind of the difficult part. And the kind of the main idea is we want to pick, whatever we pick for u, it should simplify when we differentiate it. And when we pick dv, it should be something that's easy to integrate. So in that last integral, kind of what did we do? We had x times e to the x dx. And the idea is we have this function we're trying to integrate. And it can be helpful to kind of think about what are the two different pieces or parts of your function. So we have two different parts here. We have the x and then the e to the x. So you can kind of just, let's write those out separately. We have x and e to the x. And whichever one we pick for u, it should simplify when we differentiate it. And that's what we saw. When we picked u equal to x and we differentiated it, it simplified nicely. into just 1 and then times dx. So this x term simplified. It went from being a variable to just 1. So that was pretty good. And then when we picked dv to be that e to the x and we integrated, well, that was also satisfied this other condition. E to the x is easy to integrate. So when we integrated that, it was easy to do. It was e to the x. So when we do these integration by parts, it's going to be helpful. Look at the function and then just try to break it apart and see what the different pieces of the function are. So this is kind of one strategy to keep in mind. Another strategy for how to actually go about picking the different pieces of your function is with an acronym. So we can remember this LIATE. Another way is, if you want to remember this, this has got a nicer little ring to it, ILATE. So both work. And what each of these letters stands for, just kind of rearranged it a little bit. But what each of these letters stand for is a type of function. So the L stands for log functions. I stands for inverse trig. A stands for algebraic. So things like power functions and polynomials. T is trigonometric functions, so our regular trig functions. And then E is our exponentials. So the idea here is you want to look at each part of your function and then kind of categorize it as to what it actually is. And then you pick U to be anything that's higher up on this list, and you pick dv to be anything that's lower down on this list. So in our last example, what did we have? We had the integral of x times e to the x. And we kind of broke that apart into its two separate parts. So we said we had an x term and we had an e to the x term. So x is algebraic. That's a polynomial. So the x term kind of fit here on our hierarchy of functions here. And then the e to the x, well, that is exponential. So where does that fall? Well, it falls down here. And so the way this acronym, way you can kind of use this acronym is things higher up on, whichever one's higher up on this hierarchy here, that's what we're going to pick for u. And whichever one's lower, that's what you're going to pick for dv. So in our case, we picked x to be our u because that was higher up. And then we picked e to the x to be our dv because that was further down. So this is just another way to kind of help remember how do you actually choose the different kind of parts of your function for the formula. All right, so we're going to try another few more examples in class just to get the practice for this. But we want to keep this strategy in mind. ILATE. All right, so we'll see you then. Bye-bye.